Hi class, today we are beginning a new lesson, lesson 27, and I'm on page 555. I'm going over the family letter because I think that it gives us some really good visuals on how we can think about this lesson prior to actually going over the content. So what it is telling us is that we can use models to help us compare decimals. And the two decimals we have to compare are 6500ths and 7/10ths. And what we have here is a hundreds chart with 6500ths colored in, and then we have a tenths chart over here with 7/10ths colored in. And you can see visually how 7/10ths is actually going to be bigger than 6500ths because 6500ths does not complete 7 full tenths of the hundreds chart. And we can see that if I wrote out 1, 2, 3, 4, 5, 6 columns here, this is also 6/10ths, and then we have 5 more that are there. But this one over here has 1, 2, 3, 4, 5, 6, 7/10ths actually colored in. So one way that we can compare decimals is by using models such as tenths charts and hundreds charts. But sometimes those are a little difficult for us to draw on our own. So another way that I like to think of how we can compare decimals is when we're dealing with tenths and hundredths, we can go ahead and just try to convert the tenths to hundredths so we can see that. And we know that this decimal 7/10ths as a fraction is actually 7/10. And now what I have to do is I have to make this fraction right here have a hundredths denominator. And remember, in order to do that, we multiply our denominator by 10 to get 100, and whatever we do to the denominator, we have to do to the numerator as well. So we see now that our decimal 7/10ths, written as a fraction 7/10ths, is equivalent to 70/100ths. So then when you're comparing 6500ths, which is this decimal over here written as a fraction, to 70/100ths, you see that the 70 is a larger number than the 65. And we can compare them equally because the denominators are the same. The third way, if you don't want to convert, as I've shown you here, that you can compare decimals is by using a place value chart. So what we have here is we have the 6500ths written in, and then we have 7/10ths written in, and when we converted it, we saw it was 70/100ths, and so we just filled it in as a 70, and you can already see that 70 is a greater number than 65. So again, 0.7 or 7/10ths is going to be greater than 6500ths. So we're going to apply these concepts of modeling to our first learning lesson, which is on page 557. And our word problem here states, Kelly and Casey each buy equal-sized bottles of water. They each drink some of their water. Kelly now has 5/10ths of his bottle left, and Casey has 4/10ths of her bottle left. Who has more water? Now, some key words to cue in on in this word problem is the fact that the water bottles are equal sized. And it's important that they're equal sized because then we know that the parts they're broken up to are equal parts, just like our other fractions. So I couldn't compare, a large pizza to a small pizza and say that a quarter of each of those pizzas was the same because I have a large pizza and a small pizza. So it is always important to know if they're equal-sized wholes that we are dealing with when we're dealing with fractions and decimals. And then the information we have is that Kelly has 5/10ths of his bottle left and Casey has 4/10ths of her bottle left. So this is what is left over, and Casey has 4/10ths left. Who has more water left? So I'm keying in on all those keywords. So I'm looking at the numbers 5/10ths and 4/10ths. So over here on the math toolkit, it says that we can use base 10 blocks, tenths grids, hundredths, decimal, place value charts, number lines, and index cards. And I'm going to go ahead and demonstrate for you the tenths grid to start with. And again, I think that this one is kind of the more difficult and more time intensive of the different ways that you can demonstrate this, but I'm going to go ahead and draw that for you. So I have my tenths charts, and they should be equal sized, but because I'm not using a ruler, they're not going to be perfect here, but we're going to assume that these are two equal sized charts. And you can see I got a little big on the end there, but that should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, we're assuming that those are all equal. Okay, and then we're going to say that this represents Kelly's 5/10, and this represents Casey's 4/10. And when I shade those in, I'm going to say that I have 1, 2, 3, 4, 5 columns shaded in, but on this side I only have 4 columns shaded in. So because I've shaded in 5 columns over here and only have 4 over here, the 5/10 is larger than the 4/10. Now, I really like and prefer to use place value charts or number lines, so I'm going to show you the place value chart method that we went over in our previous lessons. So we're going to have the ones place, the decimal, and we just need the tenths place for this one right here. So I'm going to make my little place value chart, and then my first number is going to be the 5/10 for Kelly and the 4/10 for Casey. Now, it's very important when you're comparing decimals in a place value chart that you always start in the tenths column. And the greatest number that's in the tenths column is going to be your higher number. No matter how many numbers are after it in the hundreds or thousands column, if you have a greater number in the tenths, this number is going to be higher. It's going to be the highest number. So I can already see that 5 is greater than 4, so this is my greater number. And the final way that I can model this problem is to use a number line, which I've checked off right here. And I'm just going to have a number line, and I'm going to break it up into tenths. Okay, so I have 0.1. I have 2/10, 3/10, 4/10, 5/10, 6, 7/10, 8/10, 9/10, and 1 whole, which is and then I have 1 whole right there. So if I plot these, so at 4/10 right here, this is Casey, and then at 5/10 I have Kelly. So I know right here, because this number is greater to the right on my number line, that Kelly is, again, the greater number. So when I write out that comparison, just like other comparisons, I'm going to go ahead and do my greater than sign, because 5/10 is greater than 4/10. And essentially, this is what we're working on for our next 2 pages. So you can begin your work on page 559 and 560.